Okay, by my watch it's 8 o'clock, so we're going to start the contest. We have fantastic contests this year. We have arguably the fastest mouse in the entire world. We have one with a video camera that's going to take a picture of the whole maze from the start square and go directly to the goal. It's going to be fantastic. So we'll start right away. PicOne Turbo, and I'll explain to you while it's running what the rules and what the goal of this contest is. Probably most of you know, but there might be a few people that haven't been there before. Okay. Is it armed? Okay, so the goal is to build a robot that can find its way through this maze. The robot knows where it starts, which is one corner of the maze, and it's trying to get to the middle. The middle is the square there that has one post in it. So there's 4 squares in the middle. Any of those would be a legal goal. It knows that this is a grid made out of 16 squares by 16 squares, and it knows that each of those squares is 18 centimeters from center to center. So, but what it doesn't know is where we put the walls this time. And so the walls are changed for every contest, and we design a maze ahead of time. We design a maze ahead of time, and then it's set up right before the contest. So the contestants have been working here for the last day or two to practice so that they get used to the conditions and everything, but this particular pattern they haven't seen. Now, each contestant is given 7 minutes, and you get 7 starts. So this one has started for the second time. So he'll get 7 of those if he wants. The scoring is basically trying to get you from the beginning to the middle as fast as possible. So the time from the beginning to the middle is called the run time. And we don't count the time that it comes back. You don't get any benefit by coming back really quickly. But we do penalize you for taking a long time to search. And so 1/30 of the time that you spend prior to each run is called the maze time. And you can see up there the maze time is getting bigger and bigger. So on your first run, you have no maze time. And on the second run, you have all the time prior to that. 1/30 of the time that you spend on the maze is added to your run time. So we're trying to encourage you to search efficiently. That's basically the goal. By and large, the search is much less interesting than the actual runs. And so we like to encourage the entries. Now, we also want to encourage you to have it as autonomous as possible. So if you don't touch it before a run, then you get a bonus of 2 seconds. And if you do touch it, then you lose that. And so there's a benefit to trying to make it autonomous. Unfortunately, it turns out that as the entry is running through the maze, it usually, the tires get dirty. And so high performance usually requires that you have clean tires. And so it's always a quandary whether to stop and clean the tires and get that penalty or whether to try to do it without. So most people do both strategies. So did you decide to start it again? Okay. So I think I have programs here. Let me pass these out just to people that are interested. Let you pass these around. And I have some more. But they have descriptions. Yeah, can you just give me that stack? I'll take it to the other side. It has descriptions of all the different entries and some technical information about them. So I'll just put these over here. Would you like take a couple? Whoops, I'm sorry. I didn't mean to do that. Okay. Okay. There you go. And just put them on the chair. Oh, no. Last year you did really well, I think, right? But the improvements, you never know. Right? It's improvements in quotation. So sometimes it's helpful, sometimes it's not. But it was doing well during the rest of the day. So these entries, typically this would be considered a wheelchair design. So it has two drive wheels on each side, 2 electric motors that are used to control each of the drive wheels. And then they usually have infrared sensors that are used to identify where the openings in the walls are. And then the sensors are also used to guide it. And so they're used for 2 different reasons. What runner we got? Yeah, you're almost done. You don't touch this only once. You don't have to touch it. Yeah, you only have to touch it once. But it doesn't matter. It just sets the flag. Oh, all right. Well, sorry about that. Yeah. Okay. All right, let's have the next entry from the University of Portland. So I think this is their first time at APEC, and we're delighted to have them here. Are you ready? If you want to talk, I'll be happy to give you the microphone, but most people get nervous. Well, that's cool. To do a turn the long way around.
We'll see if he knows where he's actually going.
We have a lot of autocorrect on him, so he'll actually autocorrect himself while driving. But in doing so, he might lose where he thinks the center of the maze is. So we'll see if he gets there.
It's always difficult when you design the maze to figure out what kind of level of maze to make. So at APEC, we often have a lot of contestants from around the world. And so to be able to differentiate, you end up with a fairly long path. So it makes it a little bit difficult for some of the entries. It'll come back. Yeah, make sure that you don't take any flash pictures. Flash are not allowed. They upset the sensors on the entries, and they sometimes put mistakes into their maze map as a result. There's more room on the far side, so you can either go behind the screen or you can go around the back if you want. If we could wish it in, we certainly would. What happened? It turned around?
No time soon.
45 seconds.
Yeah, we want some time. That's okay. Doesn't seem like it. We're out of time. Oh no, we have like 30 more seconds.
20 seconds, yeah.
Yeah, yeah. No, that makes sense. We should do that. So the way our mapper works is he prefers to go to cells that he hasn't explored yet, keeping in mind where the center of the maze is. But at this point, he's just looking for new stuff. Yeah, there he goes.
Time is up. Well, that was a pretty good try. So, University of Portland, thank you. Okay, the next entry is one that I've been talking about all weekend. This is a fantastic entry. This is the first time that someone has successfully made one that has a camera on it. So this entry is going to take a picture of the maze from the start. Go ahead. Yeah, this time starts when he leaves the start square. So it's going to take a picture of the maze. It has a camera that's, you can read about it, but basically on a little stalk, it's going to go up, take a picture, couple of pictures, bring it back down. It's going to think about it, and then when it's ready to go, it'll take off. And in our rules, your time on the maze actually begins only when you leave the start square. So he's not penalized for any of this time. So now it's going to be thinking. Thir 30 seconds to do the computations. So it's take this funny picture of the maze, and then it flattens it so that it's as if it was from the an overhead view. And then it uses that. It tries to align where the posts are so that it knows where the walls are supposed to be, and then it does its calculations on that. Here we go. Yeah. Hey! All right. 27.8. So there was no penalties or anything on that run. That was perfect. The picture was taken when the arm was up. Did you see it at the beginning? Ah. It turns out that it only goes up about 18 inches, right? It can see the whole maze. The thing about it is that it's a color camera, so it can tell the difference between the red top and the white walls. When we originally thought about doing this, we thought you'd want to be able to see the difference between the black floor and the white walls. To do that, you have to be about 6 feet up. But because he can do the difference between the red and the white, he can do it from a much lower angle. This has a processor that he designed himself, implemented in an FPGA, and he works with a compiler that he also adapted himself for his own processor. All right. That's pretty much the same time. Oh. Yeah, well, it has the touch penalty, right? Yeah. He's from Japan. It's not a university, right? Yeah. So there's a few private individuals that still participate in these things. Okay. Are you finished? Or you run again? Okay, good. No. Yeah. I know that I was going to put that in, but I didn't. Unarmed. Yeah, exactly. So I saw this for the first time in Japan this year, and so I was really pleased to be able to have him come and show this here at APEC. All right. So that's faster, right? 7. So that run was 24.7 seconds. It's a little bit faster than the first one, but it has more penalty associated with it, so it's not a better score, but it is faster. I think the first run was 27.8, so he's picked up some time. Oh, all right, this is max speed coming up here. All right, thanks very much. All right, so we got to write down the numbers, right? Wait, if you not don't look at it. Yeah, quit will do it too, right? What is it? Is it run data, right? Okay.
I can do this.
Okay. Yes.
They're in swamp.
Oh, okay. All right. So the next entry is Tsubasa from Taiwan.
Is there an infrared light that's being used to check the gate?
Yeah, yeah. It's flashing. I mean, it's pulsed.
Okay.
Right. The rules say that you may have a sensor across the start and finish. That might have been an issue. Okay, it's pulsed, so it's not on a lot, but it could interact with your sensor also. They're at 1 centimeter high, and they go across. Right. Yeah. So that's unfortunate. You're right. So we have 4 entries from Taiwan this year. We have 2 entries from Japan. You just saw 1, and we have 4 teams from the U.S. and 2 teams from the U.K. Ah. What was that first one? That's okay. No, it's okay. I got it. So you always try to do 1 run without being touched. And then if that fails, then you clean the tires and basically just incur the penalty. Oh, dear. Yeah. With a timer. Right, right, right. All right. Oh. So we're recording two things up here. One is the score, and then one is the run time. So we actually award first, second, and third prizes based on the score, and then we also give a prize for the fastest run. So everybody is trying to do the best in both categories. All right. One, 7, 7. Okay, so at this contest, I have two hats. I'm the organizer of the contest, but I do have an entry. So here we go. It's not quite in the league with the Taiwanese entries. We'll see how well it does. It's usually bad to talk about it, but I will anyway. So this one is bidirectional. It's completely symmetric. And so it doesn't turn around when it gets to a dead end. That's not worth a great deal. But it turns out that I like to have sensors at the front and the back when I'm going down diagonals. It helps me to understand whether the entry is heading in the wrong direction and keep that separate from whether it's offset. So that if I'm heading in the right direction but I'm slightly on one side or the other, I want to do something different than if I'm actually heading toward a wall. All right. The other thing that I decided that I could do is if I'm retracing my steps and there's a diagonal along the way, then I'll do that. So I don't do diagonals when I'm first searching. So I'm in uncharted territory. I always do 90-degree turns. But when I'm retracing my steps, then I do the diagonals. Since I don't search at such a high speed, I need sort of all the help I can so that I don't get too much maze time as a result. Sometimes people don't fully search the maze when they work on the APEC contest. They'll search toward the beginning, and then they'll search on the way back, and they may search and then just run, okay? I've actually set this up this time so that it would try to find the best path before it actually makes its high-speed run. That's not always a good strategy, but it's what I happen to have today. So there's something that it hasn't seen yet that it's interested in. We don't always know what they're thinking, but there we go. All right. So the little red light, you know, we use them for whatever we need to, but at the moment it's programmed so that when it's done searching, the red light comes on. It will auto start. You're supposed to sit in the start square for 2 seconds before you take off. So we'll see. Yeah.
The runtime was 13.949 and the score is 21.27. question is, when was the first Micromouse contest? It was in 1985. It was started. That was the first. Okay, well, Dave will tell you the story.
Okay, the next entry is going to be Turtle 32 from Taiwan. So in terms of the history of the contest was first proposed by the editor of IEEE Spectrum, Don Christensen. He proposed it around 1977, and it was run at the NCC National Computer Conference in New York City in 1979. And on that contest, the maze size and everything was pretty much the way it is today, but the start was on one edge and the goal was on one edge. So this was introduced at the time when the microprocessor first came out. Everybody was all excited about this contest. A lot of people came, a lot of people made entries, but it turned out the one that won did not have a processor on it. It was a wall follower, and it just had a motor and an arm and a switch, and it was able to get to the goal, get through the maze, because the goal was on the outside. And so the people in the United States were very depressed because their brand new contest turned out to be not what they had hoped for. But a very bright fellow in England realized that if he moved the goal to the middle, and if you had a string of open walls around the middle, that you would be able to get rid of the wall followers, and that you would have to make a smarter mouse. And so he, in 1980, redesigned the contest and ran it that way. And this was in England. And at that time, there were some people from the Japan Science Foundation, and they saw the contest running in England, and they said, this is a good idea. And they organized, again in 1980, actually, to have the first Japanese contest. And in 1985, the Japanese decided that they wanted to have a world contest. And so they sent mazes to all the countries that they thought would be able to participate. And they had this giant contest in 1985. So it turned out at that contest, the Japanese won handily. And the best Japanese entry was half the speed of the Japanese. It took twice as long, and it was from England, and the US entry never finished. So the sensors, it turned out at that time that it was televised. The light was unbelievably bright, so a lot of people had sensor problems. I wasn't participating in the contest then, and we never actually found out about the contest then after they occurred. But in 1985, we actually found out a week before it happened. And so we said, well, if there's going to be one in 1986 in the United States, then we'll organize. And so that's what we did. And then turned out that the person that I worked for at MIT was the chair, the co-chair of APEC. And he said, oh, I think we should have this contest at APEC. Those are power electronics engineers. They're people that are going to be able to actually build a mouse. Having the contest at the National Computer Convention, those are software guys. They're not going to be able to build a mouse. So we should do it at APEC. And so we've done it ever since. All right. A lot of people have talked about the camera. And the early entries for the camera, actually, people would take a notebook and fold it around the top of their staff cup sticking up with the camera just to have processing power. But typically, those cameras could only see 1/4 of the maze. And so the solution is never in the first quarter. And so they would then have to carry all this stuff around the rest of the maze. And so it was not the right thing to do, right? Okay, thank you. So what did we get? Okay, what was it? Okay, we're now changing hats again. So the question is, why doesn't the person with the camera get rid of the camera after he takes his picture? So there turns out to be a specific rule that says that you can't leave anything behind in the maze. And so that's part of that. Originally, there was some feeling that, maybe you'd like to get rid of batteries or something like that. You could get rid of them. I don't think people originally thought about a camera, but you're not allowed to leave anything behind. If the so somebody said oil slick, can you leave an oil slick? So if the contest organizers feel that you're damaging the maze, then you can be disqualified. This is a really friendly contest. People are very cooperative in terms of telling everybody about what they've done. So, basically everybody talks during the contest, and then everybody goes back to their corner and regroups for the next contest, and then they all compare notes again.
Eventually get to the middle. Once it does that, then it says, any unknown wall I don't know about is there, what would I do? And then if the path happens to go through a wall, then it will say, okay, let me go learn about that wall that I didn't know about. So it's just going to iterate back and forth till it finds the path. And then it'll start on its own. And it should wait. At least I've programmed it to wait.
So during the surge phase, we pick up a lot of lint on the tires, and so that's one of the reasons why they often crash. And you never know exactly how hot to program your first run, and that's really part of the issue. Okay. Oh, no, it's going to be good this year. The maze is intentionally designed with these really long straights, and it gives you an opportunity to go really fast, and it allows you to demonstrate that capability if that's what your entry can do. But it is a little bit risky because we don't have any data about where we are until we get to the end, and we have to slow down to make the turn. Yeah, I'm ready.
I think it'll slow down. I don't remember, but you can see it starting to overshoot a little bit. It's good. It's backed off the diagonals because it said I didn't make it the last time I tried it. So let me try a different strategy.
All right, made that one.
I think it'll try going back to diagonals. I don't remember what happens after.
All right, it did it. All right, so that fastest run was 11.32 seconds. I think you're done, right?
Yeah, I turned it off, so I'm definitely done.
Oh, okay. Your best score was 21. All right, so this is Fab 1. So while Derek's getting ready, I'll just tell you a little bit about it. This is an entry that has 6 wheels. So it has 3 drive wheels on each side. Many of the ones that you've seen so far have 2 drive wheels on each side, so the so-called modern 4-wheel drive machine. This one is designed with 6, and the difference is that the center set of wheels are 1/2 millimeter lower than the other sets of wheels. So this vehicle has the ability, when it's going on a straight, it'll rock a little bit, but it rocks back on 4 drive wheels, and so it accelerates really well. It brakes on 4 other drive wheels, so it brakes really well. And when it turns, it tends to turn on the middle set of wheels, and so it turns very accurately. The 4-wheel drive ones, everybody knew that they do really, really well on the straights, but we never really were sure at the beginning whether they would do well on the turns. But because we have gyroscopes on our entries, we're able to get through the turns even though the tires tend to skid. So you're turning a little bit like a tank when you're turning, because we use one motor to drive 2 wheels on either side. Whoa, that was impressive. Speaking of tank, now there is an express rule that says that you can't go over the walls, you can't go through them, you can't knock them down, right? Yeah. So the gyroscopes have made a huge difference, and when they were introduced, the performance of the entries went way up. The thing that we haven't been able to do yet is to use something inertial for the forward correction. So you might think of an accelerometer, for instance. The problem is, if you want to get position out of an accelerometer, you have to integrate it twice. So double integration is almost always a bad thing, right? Any kind of drift, any kind of offset accumulates very quickly. So in general, people have not been able to get the accelerometers to give them the inertial forward position. Sometimes there's one fellow in Japan that uses it together with his encoders. He has encoders that don't have very many counts because he's making them by drilling holes into his drive wheel, and then he has so he has maybe 16 pulses or something per wheel rotation, and then he uses the accelerometer to tell him what's happening between the pulses. And so between the holes on the wheel, and so that's his encoder, right, and the accelerometer, he can integrate those 2 sensors and get a really good answer. And so that's a possibility. But doing straight corrections off the accelerometers has not happened, as far as I know. That was quick. Yeah, so the question is GPS. The thing is, I don't know how fast GPS updates, but I just don't know. And it doesn't always work in conference facilities either. Yeah, the other thing that's been introduced a lot lately for building these is 3D printing. And so there's an entry at the end today that the second to the last one, I think, that has 3D printed wheels and motor supports and things like that. And there's a new version of this called Fab 2 that has 3D printed parts. And so maybe at next year's contest, that would be a possibility. So 3D printing makes it much more accessible to people if you don't happen to work at a university and you don't happen to have a full machine shop at your disposal. Oh, this is gyro free. Okay. Next time. The Japanese felt that this contest was getting too easy, and so they actually introduced a half-size Micromouse contest. And so the size of the squares are 9 centimeters instead of 18, and so the entries are all half the size. But they decided to keep the overall maze the same, so it's actually a 32 by 32 grid. So that turns out to be a sea of walls, and the maze designers don't really know what to do with all of that kind of a capability. So it's interesting, but the mice are almost as fast as this. It takes them a long time typically to search, but it's quite impressive. But you have to really be a craftsman to build a half-size mouse. So what's your thought? We never know really, but yeah, one more. Mice that don't search well are extremely frustrating because then you never get to see all the rest of the things that they can do. All right. Hey. Can't do anything. It doesn't time right. So after 7 runs, the timer stops. But well, we weren't trying to curse the run. We just don't record it. All right. Thanks, Derek. Okay, the next entry is Dao-Hu from Taiwan. right, great. Please don't take flash pictures. All right, look at that. So still not touched, right? So impressive. The Taiwanese have a international contest that they sponsor many years, usually in September. A number of us have had the privilege of going over there and participating, and they are absolutely the best hosts in the world. So touch it. I might not have touched yours. I don't know if I hit touched on yours. We can look. Wow. Is that better? So at this point, the score is going up because he has more maze time and he's touched it, right? But the times are probably going down. Right. Oh, 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 oh. This is amazingly rugged device. This has been doing this all weekend, right? And it's doing very well. There can be, if they nick it, right? But usually if it's a hard hit, it's a problem. But a lot of mice are able to, go by on a glancing blow, especially on a diagonal or something like that. But usually you consider the time will be better if it doesn't hit anything. It usually slows it down. Wow, 7.3. So that's 0.3 better than the last run. $7.299. Wow. Okay, so that's the fastest one so far. All right, Green Giant version 4.1 is next. This is the last U.S. entry and likely to be the fastest U.S. entry also. But I don't want to jinx you. We try to put them in order. We don't really know, but we try to put them in the order of what we think is the performance with the best one last. At other contests, they have runoffs, and so the final contest is based on how you do during the preliminaries. But this is a one-shot deal here, so we just guess. I ask people to grade their entries if they have multiple from a team, and then I just go with what I know from what I've seen them do in other parts of the world. All right. Oh. All right. So the wheels have encoders on them, so people often use the wheels to input data. And so you can see them pushing buttons and turning the wheels to try to pick the right option. Oh. This is your last run. You have piles of time. Yeah. All right. All right. 7.664 was the fastest time. So Decimus 4B is our next one. This is our second entry from the UK. I think untouch is too late. I think untouch is. We'll have to think about it. Well, you didn't know that when you started. There is, but I think it's already been used. Yeah. Oh, now then you can hit untouch. Huh? I don't know if it will go back. Hit you. Oh, he's gonna. Huh? Bailed. Okay, now you can hit touched and it's touched. Yeah, well, it was complicated. You have 3 runs left. It's going to work. All right. Yeah, we'll call it. In Japan, you'd never get credit for that, but here we'll do it. You have to get more than half in, or maybe all the way in, actually. Yeah, yeah. Something like that, yeah.
You go for a certain fill factor?
No, we go for two roots, and
But about how many wall? You know what I mean? What I mean by wall segment?
yeah, I think so.
Okay, so you have a certain fill factor.
Yeah.
You have a certain number of the maximum number of wall segments there are is 256. How many do you use in the?
Yeah, the question is how mazes are designed for the contest, and whether we think about how many walls we're going to use or something like that. But basically, the idea is that there are certain patterns that demonstrate the capability of the mice. And so they try to incorporate those. And there are certain patterns that are trouble for the mice, and they try to incorporate those. And so straightaways demonstrate their high speed. Long diagonals demonstrate their control, right? And there are certain patterns that are not very favorite. There's none in them in this particular maze, but there's one where the mouse has to go through a series of where all it sees are posts, and so it's like a comb. So it's like here, and you go this way, and there's just walls. And so you're going down this section, and you don't see walls alongside you. You only see the posts, and so you get information very infrequently, and it's very different than when you can servo off the walls all the time. And so those are patterns that are often put in. And then if you think that the contestants are really good, then you're going to try to make as long a maze as possible. And the last thing is, it's unclear when you leave the start square whether you're going to sort of turn left or right at the first Y. And it would be nice if those two paths are approximately the same, because if it makes a big difference, then luck has a lot to do with how long it takes to search, which is undesirable. Okay, very good. Got it. Missed this one. All right. I'm not, it's getting worse, so I don't care. Yeah. So this is now the fastest, it has the fastest run. It doesn't have the best score, but it has the fastest run. The previous record was 7.299, and this is 7.270. So thank goodness we measure to 1,000th of a second. One 165. Wow. Yeah. Wow. All right. Thank you very much. Okay, that was outstanding, but we have one more to go. So this gentleman, if you read the program, you'll see that he's actually the gentleman that first proposed this four-wheel drive configuration. And so you may see a number of mice that look a little bit like his. I just want you to know that he's the one that did it first. And he won in Japan, so he was the best at that time. We'll see how he does today. The unfortunate side effect of being really good is that you end up going really last, which is usually fairly nerve-wracking. Auto start? Yeah. Oh, when it's ready. Soon. All right. This year on the program, I've actually included a number of websites. So if you're interested in any of these things, you can get additional information on a number of these entries. All right. Hey, the 7-second barrier has been broken. Ah. Yeah, okay. Are you ready? Are you armed? Oh. This is not common. Oh dear. All right. Well, fortunately, he had already got the fastest run. All right, just give us a second to put everything in order. Okay, so this is one. No, we're just, this is the time. Right? All I care about is first, right? I guess that's 2, right? How are we going to check? Yeah. What's right, right.
No, okay, second round, because you only do the auto start for the first round, right? Yeah.
Yeah, you can stop it now.
So the first round, second. So then this is untouched because he did
11.83 is untouched, right?
Yep, that's auto start.
Okay, so that's the one that gets